Hello viewers, today we will be dealing with likelihood ratio test statistics, which is a output of an logistic regression analysis, and we will also see how is likelihood ratio test statistics interpreted, and we will also see that what is negative to log likelihood in SPSS output, and this is an output from logistic regression analysis in SPSS. So lots of us gets confused in interpreting the output. And today I'll be dealing with this chi-square value here and the another next value, which is negative to log likelihood. I'll be dealing with these two values, how are they calculated and how will we interpret them. This is a fixed data. Here we have two variables. The first variable is prosthetic specific agent, and this is a level of prosthetic specific agent in blood. And next we have another variable, which is prosthetic cancer, and which has been represented as either yes or no. 1 is yes and 0 is no. So here we are trying to see if prostatic specific agent level, also known as PSA level, predicts prostatic cancer or not. So PSA level is a predictor here, and prostatic cancer is a dependent variable here. So first we'll see how is this analyzed in SPSS. This is the same data in SPSS. Here we are trying to predict prostatic cancers with prostatic specific agent level. So we'll first go into analyze, regression, binary logistics, and then we have put the prostatic cancer as a dependent variable and prostatic specific agent level as a predictor. Then we'll go into options and we'll say classification plots, Asmer Lemisa goodness of fit test, and confidence intervals for odds ratio. We'll continue with the test. When we continue with the test, we see that in the beginning we get a block 0, which is a null model, and in a block 1, this is our proposed models. Here we see a significance value of 0.003 and a chi-square value of 8.873, which is showing that the model is a significant fit. Similarly, we see negative 2 log likelihood value of 10.536, which again is showing a good model fit. When we go down, we see that PSA level is a significant predictor of prostatic cancers. Now our concern is how is this chi-square value of 8.873 calculated, how is the significance calculated, and how is the negative 2 log likelihood calculated, and how do we interpret them. We will focus our discussion on them. To make a good understanding, we'll go to the Google Sheet, and here we can see that we can see the same data, and in the third column we'll keep the predicted probability. And predicted probability is calculated in logistic regressions. Predicted probability is calculated in logistic regression by maximum likelihood estimations. So when we go back to SPSS, where we see that predicted probability has been calculated. It was calculated because during analysis we checked in a binary logistics, in a shape tab we have checked the predicted probability, so it was saved in our sheet. Now we'll copy these predicted probabilities, which have been estimated by maximum likelihood estimations, and paste them here. So this has the predicted probability. Now we will estimate the likelihood. So the formula from likelihood, we will extract it from the slide here. This is the formula for likelihood: probability raised to the y, and 1 minus probability raised to 1 minus y. Y is an outcome here. So we'll copy this likelihood formula and use this to calculate the likelihood. So what we'll do is py raised to 1 raised to y, and this is multiplied by 1 minus probability, which is raised to 1 minus y. So here we have computed the likelihood. So this likelihood value tells us the likelihood of observing these probabilities having we have already observed the success or failure. Next we will calculate the log likelihood. For this we will take natural logarithm and we'll compute the natural logarithm of the likelihood, and we'll calculate the natural logarithm of the likelihood. So these are the log likelihood values. Now we will compute the sum of these likelihood values. Now we see the value of minus 567, which is a log likelihood of the proposed model. Log likelihood of the proposed model. Similarly, we can calculate the negative 2 log likelihood. Negative 2 log likelihood, and which is also known as residual deviance. So this is will be negative 2 of log likelihood of the negative 2 times. So we get a residual deviance value of 10.53, and similarly we can get a negative 2 log likelihood value for a null model. For a null model means we don't have a predictor, we only have a dependent variable, so we'll only copy the dependent variable. So we'll only copy the 2 columns only, 2 for a null model and for the null model also. This is an observations, and the predicted probability is for a null model it's only 0.5, because we are right all whatever prediction we makes, the predicted probability is right half of the times. So similarly we calculate the log likelihood as above. Log likelihood of the proposed log likelihood as above, an above formula, and using the above formula as before, we get the log likelihood as pi, which is raised to y, and we'll multiply this by we'll multiply this by 1 minus predicted probability, which will be raised to 1 minus y. So this is a log likelihood for null model, and so log likelihood to null model. Now we'll calculate the log likelihood. When you calculate the log likelihood, so negative logarithm of the negative log likelihood, and we'll sum these log likelihood values. This is the log likelihood of the null model. So this is the log likelihood of the null model. And we can also compute -2 log likelihood. -2 log likelihood of the null model, which is also known as the -2 likelihood known as null deviance. And so we'll calculate this. That's -2 times likelihood. So this is a null deviance of 19.40. So when we compare the null deviance of 19.40 and the residual deviance of 10.53 of our proposed model, we see that the -2 log likelihood for a proposed model 10.53 is lower compared to null deviance of 19.43, which is signifying the significant fit. And when we go into SPSS, here we see a -2 log likelihood of 10.53, which is exactly similar to the -2 log likelihood computed at 10.53. So this is signifying the significant model. So -2 log likelihood should be as low as possible, and it should be compared to the -2 log likelihood of the null model. Now we go into our next sections, where you compute the likelihood ratio test statistics. And to compute the likelihood test statistics, we go into the next slide, where we calculate the likelihood ratio test statistics, which is calculated taking -2 log of likelihood null model divided by likelihood proposed model. So the ratio of likelihood null model and likelihood proposed model. So this is the likelihood ratio test statistics. By the logarithm rules, there will be a minus sign. So log likelihood null model minus log likelihood proposed model. So we'll use the values from above before, 9.704 for log likelihood null model, which we computed here. Log likelihood null model. So log likelihood null model 9.70 was computed. Similarly, log likelihood of proposed model was computed as 5.26. So when we do this computation, we get a value of 8.873. This is the likelihood ratio test statistics, and we can see this is also this in output of 8.873. So this value in SPSS output is a likelihood ratio test statistics, which was computed here 8.873 likelihood ratio test statistics. So likelihood ratio test statistic was computed as 8.873, and now we can check if this 8.873 likelihood test statistic is significant or not. Since this follows chi-square distributions, we can check for the chi-square table, and for there is only one parameter, so there is degree of freedom is 1. So for that 7.87, our chi-square statistic is larger than 7.87, which was 8 point something. So we will need a calculator, and I will use a calculator here. We have a degree of freedom 1, and chi-square value for us was chi-square value for us was chi-square was our value for us was 8.872. So we'll use that value to look for the significance 8.872, 8.872, and calculate the probability. And so we'll calculate the probability, and I think we'll have to refresh the page again. So degree of freedom was 1, and so when we calculate the probability, we can see that it's 0.0029, which is approximately 0.003, which is computed here. So hence we know how was this likelihood ratio test statistics computed, how was the significance computed, and how was this -2 log likelihood computed. So in next video we will be talking about computing AIC.